Yeah, look, it's great to be here. I don't think I've talked to the Wellington Rotary Club. I've talked to other Rotary clubs, and I usually find in other regions that you guys are a lively bunch and you're pretty well informed. So I could be into trouble. So I'll try to use all my time and limit questions. Climate change is something you can't get. It's a bit like the Treaty of Waitangi. It pervades everything we do. Climate change is everywhere. It's part of our legislation. It's part of our community discussions. It's a part of discussions at all levels. And some people are sick to the teeth of it. We all have an opinion on it. And I think by and large we're a little confused about the science. What should we believe? What's real? What are scientists really saying? And perhaps what are some things that there's a little bit more uncertainty around when it comes to climate change. So in this brief 15 minutes, I'm going to try and tackle this topic and really, I guess, summarise very briefly for you things we should stop arguing about, things that the science is very clear on and we should just move on about. But there are some other things to do with our climate futures and what we may do in the future and what decisions we may take that create those futures, where there's a little bit more uncertainty about the sort of climate impacts we might get. So let's just jump straight into it. There's the temperature curve up the top there. It's a pretty noisy looking thing, but if you take out the variability there, the internal variability, and you average things per decade, it's a pretty clear warming trend in the latter half of the 20th century into the 21st century. And it's pretty clear each of the last 3 decades has been successively warmer than the previous one. We don't argue about that. The IPCC report, which Peter mentioned, that I was a lead author on, is very clear on this. It's unequivocal. The world is warming. We don't need to argue about that anymore. There is a little bit of debate about the last 10 years, of course, and sceptics like to grab that and say, oh, it hasn't warmed in the last 10 years. Well, the bad news is, unfortunately, 2014 is the warmest year of the last 2,000, and certainly the warmest year on average globally since the instrumental temperature records have been going for about the last 150 years. We can talk in question time about this, but internal variability is not uncommon in these sort of records, but it's the long-term trend that I think is very clear. Okay, the second thing is that carbon dioxide, that greenhouse gas, has accumulated in the atmosphere to an unprecedented level in the last 150 years since the Industrial Revolution. This is a curve showing that we're now up to 400 parts per million in the atmosphere. This is where we were at the beginning of the Industrial Revolution. This is both from ice cores from Antarctica, which trap gases in the bubbles. It's also from measurements more recently in the last 50 years from the atmosphere by observatories. Now, if we go back 800,000 years, we see that carbon dioxide in the ice core record does go up and down. There it is today, but it never gets above 300 parts per million. It is at 400 parts per million now. And just out of interest, this is the temperature record from the ice core record, and you can see that when carbon dioxide goes up or down, temperature almost follows it exactly. Temperature and carbon dioxide are intimately linked. Right, where are we heading? Okay, so here we have the actual measurement from the atmosphere taken from an observatory both at Bering Head, but this is the Mauna Loa one on Hawaii. And you can see the seasonal signal as carbon dioxide increases, and that's what is often referred to as the planet breathing. So in the winter, of course, the trees in the northern hemisphere all lose their leaves. They don't take up as much carbon dioxide, and then, of course, in the summer they do. It's a very real measurement, and you can see the increase. But what I find quite intriguing is that oxygen is going down. We've got a lot of oxygen in the atmosphere. We're not going to suffocate, but the oxygen is going down because it's being burnt. It's being combusted when we burn fossil fuels to produce that carbon dioxide. So there really is no argument scientifically against the fact that carbon dioxide from the burning of fossil fuels has created the temperature rise we've seen over the last 50 odd years. We can put that one in the bank and not argue about it anymore. Okay. So the IPCC says that with absolute confidence. It says it with 99% confidence, that, which is a very strong statement, any scientist will tell you, that the human influence on the climate system is really clear. This is a bit of a complicated diagram, and I'm not going to go into all the details in it, except to say, if you take the temperature record over the last 100 years, which is that black line, that's what we've measured using thermometers, and then you use a computer program, a computer model to simulate that, and you don't put in the greenhouse gases we've produced, then you can't replicate that temperature record. It's the blue area. The pink shaded line is what you get when you put the greenhouse gases into that computer simulation. You have to have them to explain the temperature record. Okay, so let's move on. And I know, you know, this is often in the newspapers, this is the poster child of global warming, is the Arctic, and the fact that this sea ice here that forms every winter is now melting. Almost half of it has gone now in summer. The winter sea ice, more than half of what we used to have left in summer is gone, and all of it will be gone in the next 50 years. So the Arctic becomes this open, accessible basin. Obviously, this presents major issues for those nations, some good, some bad, the Arctic nations, but an ice-free Arctic is a future they're grappling with at the moment. The other thing that's happening is the warming is so significant that the Greenland ice sheet is now melting from the top down, and it's melting all over. It actually rained on the summit of the Greenland ice sheet for the first time in 2012. So that's what the Greenland ice sheet looks like on the top. It's melting, these streams go through the ice sheet, they get to the base of the ice sheet and they help the ice sheet slide, goes into the ocean. That meltwater is contributing to sea level rise. The glaciers, of course, in the high Arctic and all around the world are retreating as a consequence of that warming. This is a big glacier in Alaska 60 years ago. This is that glacier today. The Franz Josef Glacier will be gone, and along with the Fox Glacier in the next 100 years by the end of the century. In fact, my team, I have some guys who are working on this, and the New Zealand glaciers are in fact very sensitive to climate change. Now, Antarctica. Here's the gorilla in the room when it comes to what might happen in the future. The Antarctic ice sheet's enormous, and at the moment we don't really understand how it's responding to climate change and how it might respond in the future. We do know that the ocean, the Southern Ocean, has warmed all around Antarctica. We know that 90% of the warming that's occurred, the heat that's been produced by global warming has gone into the ocean. It's an interesting thing. Global warming is actually ocean warming. The temperature response we've seen that I showed you in that temperature curve is actually subdued because of the amount of heat that has gone into the ocean. And the majority of that heat has gone into the Southern Ocean around Antarctica. So as the Southern Ocean warms up, it's getting around the edge of that ice sheet and it's starting to melt that ice sheet. And we're seeing a lot of melting along this margin. The Ross Sea's okay at the moment, but there's a lot of melting going on along West Antarctica, and we're starting to see the ice shelves collapse. These are the floating extensions of the glaciers where they hit the sea, these floating ice shelves, some of them enormous. The Ross ice shelf's the size of France. They're starting to collapse because of the warm ocean interacting with them. And it's a bit like taking the cork out of a champagne bottle. Once you remove the ice shelf, then the glaciers feeding them flow a lot faster into the ocean. So we sort of think of them like the buttresses holding up the flying buttresses holding up this Gothic cathedral. You take away the buttress and the walls collapse, and that's sort of what's beginning to happen with the Antarctic ice sheet. Right. Okay, so here's an ice shelf the size of Lake Taupo in 2002 in the peninsula in Antarctica. Here it is 2 months later. because of ocean warming, and that ice shelf's gone. The glacier's feeding it. The glacier's feeding it here, coming off the Antarctic continent, sped up by about 8 times as a result of that. Okay, so there's some of the changes we're seeing because of this warming. And the two take-home things is, yes, the world is heating, and yes, the world is warming because of us, and yes, the world will continue to warm. But how that happens in the future and the sort of changes we might expect is not straightforward. And our climate futures will depend very much on what we as a growing population do with energy. Okay, so this won't be new to you, but by 2050 we're expecting 9 billion people on planet Earth. And one of the key questions that will determine our climate future is how we provide the energy needs to support 9 to 10 billion people. This is a bit of a distraction, but it's sort of interesting. What would it take, for example, if we decarbonised the economy and went to green and renewable energy? To support that population, it would take 18,000 of the world's largest dams, 23,000 nuclear power stations, 14 million wind turbines, or 36 billion solar panels. Oh, thanks, Lee. So it's an either or.
23,000 looks good.
Nuclear power stations, you go for that. Or you could do this. You could have 36,000 new coal-fired power stations to... So it's a big problem. I'm not trying to be judgmental here. I'm just pointing out the scale of the problem if we are to wean ourselves off fossil fuels. Okay, I'll move it along. Now, we did think peak oil might come along and change some behaviour, make the price of oil too much and force a change to a different type of energy source. But of course, that all ended with the discovery of tight oil and gas, which we're now fracking out of reservoirs we didn't think we could get oil and gas out of. And of course, that's a game changer for the US. They'll be self-sufficient, along with Canada, in the coming decades, and really has pushed that peak oil out now decades into the future. And so there's not that incentive there necessarily to change. So let's just look at some futures. Oh, there we go. I'm going to look at 2 M-member futures. One in which we reduce our emissions heavily and we take strong action to keep global warming below 2 degrees above what it was at the beginning of the Industrial Revolution. That was the IPCC, the United Nations target, to prevent the so-called dangerous climate change. The other path is the path we're on, which is the red path there, which is what we call the business as usual scenario with low action. And in that path, we essentially burn all the easily recoverable oil, gas and coal by the end of the century, and we put 2 trillion tonnes of carbon into the atmosphere. The world is 4 to 5 degrees warmer, and that's double at the polar regions. So they're the 2 end-member scenarios. The blue one is actually very hard now, and I think that's important that people understand this. There's a lot of people running around saying we must stay below 2 degrees, but to do that, what we essentially have to do is, so this is the rate at which we put carbon dioxide into the atmosphere. This is the path we're on, and this is 2100, the end of the century. So to stay below 2 degrees, we can go for another decade at the rate we're going using fossil fuels. Then we have to reduce all emissions to 0 by the end of the century. Right? No carbon dioxide from the surface of the planet by 2100. Ain't going to happen. I'd love it to happen, but it ain't going to happen. And I think our preoccupation with this scenario is not necessarily all that healthy. And in fact, it's given governments an out. Governments are saying, well, what can we do about it? That's impossible. That's never going to happen. So let's forget about mitigation. So the world we're moving into is somewhere between the blue and the red, hopefully not the red. And so my only political comment in these sort of talks is, let's prepare for that world, because it is going to happen. It isn't going to be the end of the world, but it is something that I think we put our heads in the sand over and we don't really take very seriously, but it's coming at us. Okay, so what does that world look like? The IPCC will tell us sea level will rise by 1 metre. And that's the business as usual scenario, 0.5 metre if we take action. The problem is the Antarctic ice sheets, as I said, are still a very, very large unknown. And all bets are off, according to the IPCC. They have this get-out-of-jail card that says, well, don't believe us if the Antarctic ice sheets do something unpredictable. And the thing we know is that when we make model predictions, this is the yellow space here, and go along subsequently and measure what actually happened to sea level, it's always above the upper bound of the models. Oh, look, I won't talk too long about this, but just to say the latest science is starting to suggest numbers of 1 to 2 metres of sea level rise could come just from Antarctica by 2100. But I want to caution that it's one study, and a lot more studies are needed before we get too concerned that the 1 metre might be wrong and that we could be looking at 1 to 2 to 3 metres by the end of the century. But even if it's half a metre, and I'm going to finish on this, even if it's half a metre of sea level rise, which is the best case scenario, what will happen is the increase in coastal inundation and flooding will increase by a factor of 3. And what that essentially means is by 2100, annual events become daily events. So the 1 in 100 year coastal flooding event becomes a daily event by 2100 with half a metre of sea level rise, partly because the storms are getting bigger and partly because just raising the tide by half a metre makes a massive difference. So to me, this is one of the most concerning things that we're not prepared for, and that's why I talk about adaptation. Don't need reminding of Hurricane Katrina and Superstorm Sandy. That was on present day sea level, and that is the 1 in 100 year storm. This is what Manhattan Island looks like with a metre of sea level rise and another storm like Sandy. This, of course, was a couple of years ago. You probably remember this. We had a king tide with a big storm, and it did a bit of damage to the south coast of Wellington, and at Days Bay it took out the Catherine Mansfield house right here. In fact, my friend owns this property, and he had refugees that night. He just built his house, and he decided, because he was a scientist, a little bit sceptical about climate change, but he thought he'd put his foundations up half a metre anyway, just in case, and he just survived that, didn't get flooded. Wellington City Council are taking this pretty seriously. That's some might argue it's not a bad thing if the politicians were flooded downtown, but that's what Lambton Quay looks like. So I'll just finish up on that final note, and you can just take this in a little bit. But what I'll explain this just briefly, but I think the take-home points are there are some things we should stop debating, but there are some things that I think are very important where the science isn't clear, but we know enough that we need to start acting now, and then we need to put more effort into understanding what those futures might bring us. One group that do understand right now what's going on are the insurance industry, and this is data from Munich RE, and very simply, the red bars here, so these are numbers of natural disasters resulting in large insurance claims on an annual basis since 1980, only to 2010. But very simply, the red ones are earthquakes and volcanic eruptions. They don't change. They're a constant on the planet sort of thing, except it doesn't include Christchurch, I have to admit. Nor does it include the Queensland floods and things that happen subsequent to this time series. But all these other colours are climate-related events. And so what the insurance industry is realising, that the number of large claims resulting from natural disasters is increasing, and it's increasing because of climate change. I always find this a really interesting piece of data. So yeah, thank you very much. I hope I haven't been too doom and gloom, and we'll leave it there. Thank you. The question is, the problem's a really big one, and governments come up with various strategies, but what about technology? Will that save us? Could we scrub the carbon dioxide out of the atmosphere ultimately? And I have to say, a lot of people I interact with are optimists when it comes to technology, and that we will engineer our way out of the solution. It's not my area of expertise. I wouldn't want to take the risk. I think, yes, obviously look for a technological solution, and perhaps we can find the energy, as you're suggesting, to drive that. I'm not the guy to comment on it, but from what I understand, that's a massively difficult technological challenge. So what can we do? We have this great debate. Should scientists be advocates? Should we stick to our knitting and talk about what we understand? Or should we then answer your question, what do you do about it? Because that's when I get out of my area of expertise and I start talking about my experience of talking to other people and my own personal opinions. I think it is a very difficult issue at the government level, and I don't think, because of the way governments think on short-term timeframes, 3 to 5 years, I don't think they're going to change unless we put pressure on them. So I think it's going to come from communities realising the importance of the issue and then using our vote. In the short term, that yes, you can say, yes, we can do lots of things, we can switch off lights, we can drive small cars, all that sort of thing. But what that requires is everyone to be of the same mindset. I definitely, I try to live my life that way. I hope, you all do. But at the end of the day, you've seen how short the time frame is if we're going to go and try and significantly mitigate these greenhouse gas emissions. It is going to take some globally organised binding agreement very, very soon, which governments are going to have to lead. The question is, for many of us, we've got more immediate issues. I mean, some say climate change is a middle-class problem. It's a luxury to worry about, because many of us were rebuilding our homes after the Christchurch earthquake, just come through the global financial crisis. For a lot of people, it's not high on their agenda if they were going to change their vote.